Hello, everyone. Today we're going to talk about Half-Life, not the video game, but it's a certain measurement that you take for unstable isotopes. So for unstable isotopes, one half-life is the amount of time it takes for half of that isotope to decay. So as we learned with radioactive decay, that isotopes that are unstable, they will undergo decay. This half-life will determine how long it takes for half of that to decay. So different unstable isotopes have different half-lives. Hydrogen-3 has a half-life of about 12 and a half years. Carbon-14, which we use for carbon dating, has a half-life of 5,730 years. So just a reminder of from our last lecture about radioactive decay. Um, there's a certain measurement that you could take called the neutron to proton ratio, the NZ ratio. So there's a certain NZ ratio for each atom that is very stable, for at least the lighter ones. But as you go, if the isotope has too many protons or not or too many neutrons or not enough neutrons, then suddenly that isotope or that nucleus wants to, or not wants to, sorry to personify it, that nucleus will be unstable. It is more likely to undergo decay, and the likelihood of it undergoing decay is, it shrinks, it becomes less and less, hence the faster half of it will decay, so its half-life is decreasing as it becomes more, or if it's more unstable. So how does this work? If we're talking about carbon dating, let's say a substance starts at 50 grams. How many grams are left after 9,300 years if carbon-14 has a half-life of 5,730 years? So let's find our givens. Our first given here is going to be this 50 grams. That's going to be our, whoops, you guys didn't see that. That's going to be our initial amount. So let me remember to do this. Okay. So we have this, our initial amount. We can say Ni. If you want to be exact, there's other equations that use mass. That will be mass I, so you could use either one. In this case, either will work for this. So there's going to be two times that are given. One time is going to give us the amount that is half of half-life, or how long it takes half of a substance to decay, and the other will be the actual time that has passed. And in this case, how many grams are left after 9,300 years has passed? So this is the one that has passed. We'll call this T. And then this one is giving carbon-14 has a half-life of 5,730 years. This is going to be T half-life. Yeah, so I call it T subscript HL, or you could just call it HL for half-life, and that will go in the bottom of this equation. So from here, we have our givens. And let me turn infinity. Click back into the thing. So we have our givens here. We're trying to find our total amount that is left. So what we have to do is plug in our equation. And when we solve this, this will give us the amount of mass that is left. So how this equation works is this part here in the exponent. This will calculate how many half-lives have passed for this substance. So in 9,300 years, how many half-lives have passed? We just divide it by the amount of time it takes for one half-life to pass. And this will give us that in this time 1.62 half-lives have passed. In each half-life, half the substance is going to remain. So this is going to tell us how many times we need to multiply our initial amount by 1/2, hence the exponent, right? So from here, we just do 1/2 to the 1.62 power. Then we multiply by 50 grams. After 9,300 years, only 16.23 grams of this carbon-14 substance will remain. The rest will have decayed into its daughter nuclei, which I believe is nitrogen-14. So this is as far as we're gonna go talking about Half-Life in this class. So we don't need to worry about anything else. There is more that we could do with Half-Life, but like I said, Introduction to Physics class is all that we will cover. And in the lab today, I just gave you the general methods that you will use, the general skills that I'll expect to see during this lab. You guys will actually learn a lot about carbon 14. I'm sorry, not carbon 14, but not just carbon dating, but how? Oh my gosh, sorry, I'm really tired, guys. But you guys will learn a lot about how to use Half-Life to calculate the age, or how scientists calculate the age of different things. They've used it to calculate the age of the Earth. They've used it to date back to the dinosaurs. Of course, you'll see that carbon-14 actually cannot be used, so carbon dating cannot be used to find the accurate age of the dinosaurs, but you will see what other substances can be used for that. So make sure you look at these notes first, then you'll get into your groups. And then there's a very radioactive isotope you will receive today called trachorium. So make sure you're very careful with it. Do not eat it until it's decayed. So have fun.